In this video we're going to look at the sine rule. The sine rule is a formula which is given in the exam, and it is A over sine A, which is equal to B over sine B, which is equal to C over sine C. This formula is given in the exam for you. How this formula comes about is it's taken from the area of a triangle formula, and if you equate the different areas together, you can eventually whittle it down to this formula here. What we can do using this formula is that we can calculate the length of a side in a triangle that we don't know, or we could also calculate the size of an angle. We're going to work through a few examples of each just to see how this is working in practice. Okay, in this example here, we've been asked to calculate the length of the side AB. When we are looking at problems like this, and we're going to introduce the cosine rule later, there is a hierarchy of things that you should be thinking about for deciding which formula you should be using. However, in this situation, I know that I should be using the sine rule because I'm given two angles and a side, and I'm asked for another side. To do these problems, what we're going to do is we're going to label the sides just like we did before with the area of a triangle. So the side that is opposite A is this one here. So we're going to call this A. We'll call the side opposite B, B, and the side opposite C, C. And to start off with, all I'm going to do is I'm going to write down my formula. A over sine A equals B over sine B equals C over sine C. These three ratios are equal. Okay, so what we need to do is we need to tick what we know and highlight what we're looking for. In the question, we want to figure out what C is. We want to figure out what this is. So I'm going to put a question mark next to C. I know what B is. B is 80, so I'm going to put a tick next to B. I know what the angle B is, so that will allow me to calculate sine of B. And I also know what the angle C is, so that will allow me to calculate sine C. So we can ignore this ratio, and it means that we can just work with these two ratios here. And we're going to use these two ratios to help us calculate the length of C, which I should just finish circling here. This is what we're going to calculate. Okay, so we're going to write B over sine B. B is 80 centimetres. So it's 80 over sine B. So it's 80 over sine of 43 degrees. And that is equal to C. That's what I'm looking to calculate. And that's divided by sine of C. Well, C is 37, so it's going to be sine of 37 degrees. I want to calculate the length of side C. So what I'm going to do is I'm going to manipulate my equation. I'm going to rearrange my formula and make C the subject of the formula. So I want to have C on its own. So I notice that I've got C and it's being divided by sine of 37. So what I'm going to do is I'm going to multiply both sides by sine of 37. I do that because this sine of 37 and this sine of 37 will cancel down. And if I just rewrite my equation with my variable that I'm looking for, C on the left hand side, I have C equals 80 times sine of 37 degrees divided by sine of 43 degrees. Just a note, when you're putting this in your calculator, I would put brackets around that top line because sometimes when you do this you can make a wee mistake in your calculator if you're not careful. And so if you input that on your calculator, we should find that to one decimal place, C comes to 70.6 centimetres, and so the line AB is 70.6 centimetres. In this problem, I've been asked to calculate the size of angle X in the diagram. Okay, so how to identify what formula you should use will become clearer once you've looked at both sine and cosine examples, the sine rule and the cosine rule examples. But here I know to use the sine rule because I am given two sides and an angle, and I'm looking for another given angle. Okay, so to start off with, what I'm going to do is the same as what you should always do with these problems, is just to write down your formula. A over sine A equals B over sine B equals C over sine C. Okay, so I've written down my formula. I need to label my sides, so the side opposite A, the side opposite B, the side opposite C. I want to find out essentially what angle C is here. This is what I want to calculate. So this is the thing that I'm ultimately going to be looking for. I do know what C is. C is 2.3. I know that B is 2.6, and I've got a value for the angle at B. So that will mean I'll be able to find a corresponding value for sine of B. So similar again, in this case, I can ignore this ratio here. So let's write down what we have. We've got B, which is 2.6. That's over sine of B. Sine of B, sine of 40. C is 2.3. And that is divided by sine of my angle C here. Okay, so if this was like sine of, and this was 10, you would write in sine of 10. But because this is x, we're simply just going to write sine of x degrees. Ultimately, I want to have an equation where it is x equals. I don't have that at the moment. I've got sine x and it's in the bottom of an equation. It's looking a little bit messy at the moment. What I'm going to do is I'm going to rearrange the formula to make x the subject of the formula. And in order to do that, I need to make sure that it's at the top, it's at the numerator of a fraction. I don't want it to be the denominator. So what I'm going to do first is I notice that I've got sine x on the bottom. I don't want x to be on the bottom, so I need to multiply both sides by sine x because I don't want x to be on the bottom. I'm going to multiply this side by sine x. I'm multiplying both sides by sine x because it means it gets rid of sine x on the bottom here. That will leave me with, on the left hand side, sine x times 2.6 divided by sine of 40 is equal to 2.3. Okay, I'm going to keep going. I'm going to rearrange my formula. So I've got my function on the left being divided by sine of 40. I don't want that there. I ultimately just want x on the left. So I'm going to multiply both sides by sine of 40. I'm doing that because these cancel here. That would give me sine x times 2.6 equals 2.3 times sine of 40. I want to have x on its own, and I've got sine of x being multiplied by 2.6. To undo multiplication, I'm going to divide both sides by that 2.6. And that will give me, well, sorry, I do that because now this 2.6 can cancel with this 2.6. And so I can write sine x is equal to 2.3 times sine of 40 divided by 2.6. I have now rearranged my equation to be in the form sine of x equals something. I don't want that though. I want x to be equal to something. So what I'm going to do is I'm just going to minimise this so I've got a little bit more space. Okay, so I've got sine of x is equal to this expression on the right hand side of my equation. If we think back to solving trig equations or even just generally SOHCAHTOA, if I've got sine of x equal to something, to find out what x is equal to, I would need to take the inverse sine of that. So x equals the inverse sine of 2.3 times sine of 40 divided by 2.6. So shift sine on your calculator and then put this into the brackets in your calculator. After doing so, you should obtain an answer of x equals 34.7 degrees to 1 decimal place. One wee thing to note that you're asked to calculate the size of an angle, so remember that your units are in degrees. Okay, so we identified which ratios we were using. We were asked for the angle, so we had to manipulate our equation to get the given angle at the top of our fraction in our numerator. We then further rearranged to get it in the form of sine x equal to something. Then to find out what x is equal to, we had to take the shift sign. We had to find the inverse sign of that function.